Hi, my name is Karen and I want to find the absolute minimum and maximum values of the following function. The first thing that I notice is this inequality is indicating me that the boundary of this is a this of a circle or radius 2. I just want to keep that in mind. But the first thing that I'm going to do is to rewrite this part of the equation, and easy ways for me to do it. So if I rewrite it, it's going to be like x squared plus y minus 1 square. If I have it like this, now I can take the first, the partial derivative. So I'm gonna start for the partial derivative of x, which is 2x, and now I'm gonna do the partial derivative for y, which is 2y minus 1. So having this, now I can solve for a system, so I can find the values for x and y. So I can say that 2x equal to 0, which give us x equal to 0. On the other side, you have to find the value for y. So we can say that y is equal to 1. This is important because this is going to tell us the only critical points of this function is the point 0.1. This is inside of the this radius 2. Remember that we said the radius of the boundary is 2. So then we can plug these values in the original, well, the equation that we have in the beginning. So if we have, I'm gonna rewrite the equation again so we can, be clear what are we doing. So I can set if I'm gonna plug these numbers, I can say that, substitute the value for x here and also the value for y, and this is gonna be equal to 0. This means that the function value at this critical point is 0. So the next step that I'm going to do is look at the boundaries. So remember that I told you that this is going to tell us the boundaries. So I'm going to write this down. It's going to be x squared plus y squared equal to 4. I need to solve x squared. So if I solve for x squared, it's going to be x squared equal to 4 minus y squared. This is really important because if I plug this into the original equation that we have, we can make the function related to y. So I'm gonna do it now so you can have a better idea what I'm talking about. So you're gonna rewrite this. We have this. So I'm gonna make the equation, to y like a g. Sorry, it's okay. I made a little mistake, but y is, I'm gonna put, so because I want to put this value that I found for x squared, I want to put it inside this original equation right here. So I'm just gonna substitute this value here. So this is gonna be equal to, this equal to this because I put it inside here, plus, y squared plus 2y plus 1. If I'm gonna cancel this one, this is gonna be equal to 5 because I can add this to 5 minus 2y. If I find the derivative of this equation, it's going to be just -2 because the derivative is this, the y is going to be just -2, which is going to be another important information in this to solve this problem. So having this done, now we can find the value of these points at the critical. We can find the value of this for the critical points. So I'm just gonna put, remember that I told you the boundaries are going from -2 to 2. So I'm gonna put this in this equation. So we have the G2 is like 5. We have this equation, so we can find 5 -2 to 2 is equal to 1. And we have g of -2 is equal to 5. They're on the same equation. So we have 5 -2 is equal to 9. So we're almost done. What we have all collect all this information, we can determine the absolute minimum is 0 at the point 0, 1. and the absolute maximum is 9 at the point 0, -2. Thank you so much.